Okay, dear participants, welcome to this session and the third International Congress on Human-Computer Interaction, Optimization and Robotic Applications. My name is Emir Köksal. I have been working for Mayıs University as an Associate Professor Doctor in Samsun, Turkey. Now, in this session, we have 9 presentations. The duration of each presentation is 10 minutes, including question, remark, and comments. Now, the first 2 presentations are given by Syed Ibrahim Ismail. The title of his first talk is Design and Assembly of a Smart Steamer, and the title of the second talk is Design of a Drivable Airport Luggage Trolley. Syed?
Yes, thank you, Dr. Mohammed. I will share my screen.
Okay.
Okay. Good afternoon, everybody, and welcome to the first presentation. In this presentation, we will discuss the proposed design and assembly of a smart steamer. This is a capstone project completed by 2 of our undergraduate students at the American University of Kuwait, student Fatima Al-Alawi and Dalal Brusli. Nowadays, with the technology advancements, almost all daily life essentials are being processed automatically. It is considered one of the daily essentials to have our clothes clean, steamed, and ready to be worn. It's vital that your appearance is well presented, not only in formal events, but also in simpler outings and day trips. Laundries have difficulty in informing each customer whenever their clothes are done. Customers sometimes waste time just for going to the laundry without being certain that their laundry is ready or not. Furthermore, customers may give different number of items at various times. Hence, the clothes might be at different stages of the steaming process for each customer. In addition, laundry employees find it time-consuming and tiring to gather different items related to a specific customer. The proposed smart steamer is a system that works as an automatic steaming machine to help make the laundry job easier, faster, safer, and more efficient. The smart steamer takes garments that have an RFID tag attached as the input. The information of the client is programmed and written to the RFID tag by the employees at the laundry. The proposed system will retrieve the customer information that is saved in the laundry database and contact him or her by sending an automatic notification when all items related to that customer have finished steaming. Employing this system increases efficiency, reduces accidents, and provides a good customer experience. In general, this system will be useful for both the laundry business owners as well as the customers. The smart steamer is a combination of components and interfaces connected together to establish an automated steaming system. It includes the following main components: a PC, personal computer, used as the main processing and control unit. We have also the RFID writer and reader, and of course the RFID tags that will be connected to each piece of cloth. We have also the motors, we have infrared sensors, and we also have designed or developed a user interface for the application. 2 RFID readers are used. One before steaming the clothes and one in the final stage of the steaming process to detect the finished items, decrement the number of items per client, and identify the item information. This figure presents a simplified architecture for the proposed smart steamer. As you can see here, that the heart of the system or the processing unit is the PC, which reads the information provided by the infrared sensor and the RFID. It also gets feedback whenever the clothes have been steamed. And as we'll see, those pieces of clothes will move to a secondary location or waiting room for the customer to pick them up. This table presents the main components used in the proposed smart steamer. You can see here that approximately the total cost of the proposed system, of course, this is a simplified system or on a small scale just for illustration purposes, is around $1,500. Microsoft Visual Basic application was used to program and create the main interface for users. The application has been designed to be as friendly and as easy for the users. The application is used to program the attached tags and write the items information, which include the contact number of the client and the type of material. The employee can then place the items on the moving hanger to be steamed. Furthermore, the application can be used to control the system's movement. The user has the ability to start the system, stop the system, and control the direction of movement. The application also has the option of reversing movement of the items. This is used by the laundry employee to fix information or stop the smart steamer if needed. The application shows the item status, whether it is waiting in the steamer or has already been steamed. The application checks whether the items for a specific line have finished steaming or not. If all the items under the customer number have been steamed, a notification is sent. This notification is sent through an SMS to inform the customer that the items have been steamed and are ready to be picked up. In order to filter items according to the customer contact number, a get button has been added. A filtering algorithm was developed to separate the items requested by the receptionist at the laundry. This figure presents the graphical user interface for the application. As you can see here, we have the RFID tag number and the associated mobile number of the client. We also have the control here, either to stop the motors or reverse the direction of movements. And also here we have the maximum cases or the number of items and also the waiting time. An arm is used to remove a specific hanger containing the wanted item on a separate track for a specific customer. The servo motor is responsible for moving the arm to carry the hanger and pull it up to a certain height. The infrared sensor detects clothes right before entering the steam room. The system determines how long the item should stay in the steam room, depending on the type of material. The proposed smart steamer has a square structure in order to have a steaming process in a circular motion. Of course, this is a simplified structure. The topology of the proposed design can be modified according to the space available. The main body of the smart steamer contains holders that are specifically constructed for the proposed prototype. The holders are used on the upper chain of the main body. The holders are made with a large radius of around 1 centimeter to make sure that hangers can be held firmly. The hanger has two extensions from the top. The first extension is to be attached to the holder on the main chain. The second extension is connected to an arm that is used to move items from one track to another. Steamed items are moved and transferred to a secondary stand. The secondary stand carries the steamed clothes that are ready to be picked by the customers. The steam room was designed with square sheets of reinforced plastic. The 2 squares of fiberglass are designed with holes in rows and columns that have the function of transferring the steam in and out. This figure presents the simplified prototype of the smart steamer. As you can see here, we have the holes, okay, for the steam to steam the clothes. So this is the steaming portion of the design. And here you can see the chains that will connect to the hanger so that the clothes will move in a circular fashion. This is the special hanger designed for the proposed design. As you can see here, we have the upper extension that is connected to the main chain. And here we have the lower extension that connects to the arm in order to remove the clothes to the waiting room. Here, as you can see, the first extension, the one on top, is attached to the holder on the main chain. And in the second figure, you can see that the arm is connected to the second extension of the hanger in order to remove the clothes that have already been steamed into the waiting room for the customer to pick them up. In conclusion, the design of a smart steamer prototype has been introduced. It includes the following features: an RFID, which is attached to each item, a main database that includes information related to each client, a user-friendly application, a notification system that can send messages to the user's mobile when the items or all the items have been steamed, a square structure with 2 rounds of chains wrapped on top of each other, and a special type of hanger with 2 extensions. Thank you all for listening.
Thank you very much for your first talk. Is there any question or remark? Comments? No question. Can continue.
Okay.
Your second talk.
Okay. In the second presentation, we'll talk about the design of a drivable airport luggage trolley. This as well is a capstone project that was done by one student, Hissa Al-Anizi. Technology has undergone many developments and changes within a short period of time. The worldwide acceptance of this rapid change made people rely and depend more on technology. Traveling has been an essential means of transportation from one place to another within a short period of time. Huge airports specifically take considerable time and effort for the traveler to walk from the arrival gate to the departure gate. This becomes especially of ages. Also, the proposed trolley offers a higher degree of security because it provides a safe lock for the luggage. The proposed drivable airport luggage trolley is divided into 2 main parts, the hardware and the software. For the hardware part, the process of modifying the original trolley included adding motors, wheels, batteries, and a lock system that secures the bags into the trolley. The software, on the other hand, was developed and is managed by the administrator to update the application in case of changes in flight schedule or gate numbers. The admin has access to add and edit any information that will be available on the application for the user of the trolley. Once the iPad that is installed on the trolley is connected to both the Wi-Fi and Bluetooth, it will be ready to be used by the user. The traveler can insert the information of the flight on the display screen and set a password for the smart lock. The user provides the application with the booking number or booking reference to start using the trolley. Each user is identified and distinguished by his or her booking reference. Once the information of the user is provided, the user will gain access to many facilities of the airport, such as the map, directory, and flight schedules. This figure illustrates the system architecture of the proposed trolley. Of course, here we have the trolley itself, where the movement and the direction and the speed is being controlled by the user. And the second part is the interface through the iPad or the mobile. Here we can get the user flight details like the gate number and the flight ID. Here the user also can gain access to the smart lock that is being controlled by a microcontroller, where he or she can set the password and lock the bags or the luggage to the trolley. And in the application, there is displayed the map directory of the airport that can include airline offices, the location of the gates, and also cafes and restaurants. This table lists the components used for the proposed drivable trolley. You can see here that the total cost of it is around $1,000. However, note that this excludes the cost of the trolley itself. We were given the trolley and we made modifications to the original trolley. If the cost of the trolley to be included, this will increase the cost a little bit. The application was built using Xcode and installed on an iPad device. The application is divided into two main categories because the application is designed for both the administrator and the user. The administrator can update the flight departure and arrival dates, gate numbers, and any other information related to the flight. From the user's perspective of the application, the user must register with the booking reference to get all the details. The user of the application will get an access to the airport's map directory and receive a notification of flight's latest information. The lock system for the trolley is used to make sure that the belongings and luggage of the traveler are safe and locked to the trolley. The servo motor of the lock opens or closes depending on the order received from the Arduino microcontroller. The design of the drivable airport luggage trolley was based on a real airport cart that was kindly provided by Kuwait International Airport. Changes were made on the original cart for the extra needed features, such as adding a place for the display screen or the iPad, adding housing for placing the power bank for charging smart devices, and also a placement for the battery for the motors, adding a step for the user to stand on to be able to drive the cart comfortably, and the addition of two DC motors to move the cart. Here we have in this slide the figures or images of the trolley that was provided by Kuwait International Airport. So this is the original trolley that we used in our design, and in the next slide you'll see the changes applied to this trolley. This figure presents the proposed drivable trolley. As you can see here, we added a step for the user to step on and use the trolley. This is the compartment for the battery, and here we added 2 DC motors and the wheels to control and move the trolley. In conclusion, the design of a drivable airport luggage trolley was introduced. The proposed trolley has a display that frequently updates the information of the traveler's flight dates, as well as any changes in gate number. The application also provides the user with a map of the airport for easy and fast access. Furthermore, it can be easily driven and controlled by the user and is suitable for all ages. The proposed trolley also offers a smart lock for the belongings or the luggage. Thank you all for listening.
Thank you very much for your presentation. Do you have any question, comments?
I would have a question.
Yes.
Okay.
So first, thank you very much for your presentation. There are thousands of trolleys that are used on an airport, and when I understood correctly, you could reduce the cost of your development immensely if an application could be used on the user's device, because the iPad is very expensive. So what would be the argument against an application on the user's device?
Yeah, of course, you are right. And each airport can have its own application, okay, where the travelers can download the application in advance.
Yeah.
Okay, yes, but in our case, we wanted to have the iPad because maybe, let's say, some users, the battery is depleted of their mobile phones. In this case, they can have the iPad for their own convenience. In addition, they can set the passport, right, the password for the smart lock on the spot. Okay. Of course, in this case, they have both options, either use the application on their mobile phone and also use the application on the installed iPad.
Okay, I was just thinking about the reducement of the cost when you need 1,000 trolleys and then you have to buy 1,000
yes,
iPads.
Yes, of course, you're right.
Okay, thank you very much.
Thank you.
Thanks again for your presentation.
Thank you, Dr. Mohammed.
Next speaker is Sarmat Nozat. The title of the talk is Weighted Round Robin Scheduling Algorithm in Mobile AD Hoc Network.
Hello, good afternoon. Actually, the speaker was changing to me, Samir Al-Ani, but I don't know why it's not changing the PDF file. So,
sorry? So
actually, the Sarmat was changed. The speaker Sarmat was changing to me. I mean, I will be the speaker here. I will be the presenter.
So you are the speaker of this talk,
yes,
right?
Yes, exactly. Right. The next as well.
Nice. And also next one.
Yes, exactly.
Okay.
Okay. Let me.
Okay, you can start.
Yes, sure. 1 minute, please. Actually.
Share your screen at the bottom.
Yes,
hello and good day.
Can you see my screen?
No, not now. No.
No.
Just a second.
This is your presenter.
Yes, now yes.
I'm going to present a topic which is talking about weighted round-robin scheduling algorithms in mobile ad hoc network. I'm going to present presentation depending on the following overview. I'm going to present about abstract background, research method, simulation and validation, and conclusion. Firstly, I would like to talk a little bit about the mobile ad hoc network that we call it MANET. A mobile ad hoc network, we call it MANET, is a self-directed group of mobile handlers that communicate over relatively bandwidth-constrained wireless channels. In MANET, several signals could be transferred as data, voice, and even as video streaming, which has required sufficient packet routing and scheduling mechanisms. In this work, 4 famous MANET scheduling algorithms are selected, are investigated and identified as round-robin, strict priority, weighted fair, and weighted round-robin. The MANET scenario, which is consisting of 50 random mobile nodes, is built using network simulator QualNet in version 2.0.1. As a background, wireless ad hoc network is a congregation of wireless stations that can configure themselves to form a network without the assistance of any infrastructure, as shown in figure 1 here. For mobile ad hoc network or MANETs, there are different categories of wireless networks which do not require any fixed infrastructure or base stations. They can be easily deployed in places where it is difficult to set up any wired infrastructure. As shown in figure 2, there are no base stations, and every node must cooperate in forwarding packets in the network. For that reason, I'm going to present the research method that we started over. Here, as shown in the flowchart, we started the main idea of this work by comparing 4 selected scheduling algorithms in a mobile ad hoc network in which 50 nodes are randomly distributed. Firstly, the extensive literature review is conducted in terms of definition of mobile ad hoc networks, their advantages and their applications and their issues. Next, we started designing the proposed scenario in the network emulator. Then we implemented 4 selected scheduling algorithms as we presented before, as RP, WF, RR, and WRR. And these are the algorithms that related to weighted round robin and that we have just presented. Then we started simulating and validating the work. There are many simulation parameters related to the proposed scenarios need to be adjusted before running the simulation. This table, as we can see here, represents the simulation parameters that must be adapted and checked for proper simulation results. And it is followed by simulation scenario, which is consist of 50 nodes and built-in Exata software, as shown here in the following figure. This is the overall methodology. For each parameter, its values are changed by selecting the related tab at the output view in the Exata view. Next, the elements represented the tab are selected by right-clicking on the properties and seeing each part aside. Then after the simulation has finished, the analyzer were shown as shown in the overall methodology, as we can see here in the left. After that, we started showing the optimum result, or let's say the validation, which is shown in this figure. And by exporting the result to the text and drawing the result and the figures that can be achieved, that were achieved after that as the analyzer in the Office Excel 2016. Then we started evaluating the performance of the work. As we can see here, we started evaluating the performance in different terms. We started on average throughput. The average total packets received through the network simulating in kilobits per second are important metrics. So we started seeing each part aside. As we can see here in the first one, the average throughput of the selected scheduling algorithm, we have got SP, the winner one. And for selecting scheduling algorithm menu, we have found that weighted round robin has got better results. And after that, for peak queue size, we have got weighted round robin again as the better one. As for the average length of the selected scheduling, we have got again weighted round robin as the better one. So for the average throughput, only SP was the highest one, and for the other factors, we have found that weighted round robin is the better one. Then we started studying the average time in queue. We started that by depicting or demonstrating this figure, which is showing the average time in queuing process and the wireless gateway for the restricted priority, I mean for SP, and for the weighted fair, and round robin, and even for the weighted round robin. So the restricted priority waste more time in queuing compared to the others. Moreover, that we can see here the restricted weighted round robin here has shown that the lowest average time in queuing, which means it is the fastest one. So we can see that SP wastes longer time. So again, weighted round robin in the term of time has got better result. Then we can study the total packets dropped. Here, the total packets dropped by a force when a memory buffer is full. We have got that the SP. We studied the SP, and WF, and RR, and WRR scheduling algorithms. From the figure, it is clear that WRR, weighted round robin, has dropped the least packets when the node buffer becomes full. So the highest drop is achieved by RP. In that way, so we can find that the RP scheduling algorithms dropped 23 packets in the same condition buffering. As a conclusion, we can conclude from this work that the performance of the strict priority round robin, weighted round robin, weighted fair scheduling algorithm is investigated mainly in the term of network metrics and queue management metrics in mobile ad hoc network. The results showed that SP outperformed the other regarding throughput. In contrast, WRR has outperformed the other regarding the remaining matrices: end-to-end delay, peak queue size, average queue length, average time in queue, and total packet throughput. So we can, as we presented before, that WRR has got better results. Then we started evaluating the performance in the high density of networks when several nodes transfer different levels of priority signals. Again, we have found that WRR in the term of time has got little time than the others. So we found that the other algorithms has wasted so much time compared to the weighted round robin. Finally, we evaluated the impact of the different queue priorities on the queue management metrics. And again, we have found that sometimes we have found that SP got the better, and the weighted round robin, according to the results and the analysis, we found that it has get better than the others.
Thank you very much. Any question, please?
Any questions? Comments or no question? You can present your second book.
Sure.
Hello and good day. This is your presenter, Samir Ulani. I'm going to present my topic, which has the title Localizing and Imaging of Breast Cancer based on ultra-wideband antenna sensor network. I'm going to present my topic depending on the following sections. First, I'm going to give an abstract, background about the topic, research approach, present the results, and talk a little bit about the conclusions. As an abstract, we need to show that this work examines the process of imaging and localizing breast cancer using an ultra-wideband sensor network. So we are using two-dimensional network of ultra-wideband antenna sensors, which are used to activate the object as well as capture the delayed and phase-shifted data. These data are analyzed using an algorithm that eliminated noise and the clutter, while displaying the image in a high resolution. The sensitivity and the efficiency of the machine are improved by using more ultra-wideband sensors. As a background, we need to show that this work aims to propose a high-performance breast cancer detection using a network of ultra-wideband antenna sensors. The potential for ultra-wideband sensor networks to be used in a wide range of applications like tracking, localization, and imaging. The resolution of a breast cancer imaging application is determined by the amount of the bandwidth that can be sent through the breast by the antenna. The microwave signals are sent to the breast by one ultra-wideband antenna sensor, and the dispersed signals are collected by the other. The core principle of the imaging sensor network is to use multiple antenna devices to transmit and receive radio signals in a network. As we can see here in the figure, these are the places that we have talked about. So we can use different arrays in order to make better bandwidth. When we make better bandwidth, This means that we can get better result. I mean the results of the image that we can reach. The image that we obtain will be better and clear. According to that, there will be in high resolution. As a research approach, the methodology of the work started. The antenna started setting up in a such way that can detect cancerous cells in the scalp. So, for this purpose, a few antenna arrays were simulated. The more antenna in the array, the more dispersed pulses will be collected, resulting in a more detailed picture. So, as I said, we need to use different or several arrays in order to get better results. To form a network, an umbilical antenna is selected. So, the ultra-wideband antenna sensor network is named as transmitter antenna, TX, and the receiver antenna, RX. So, from the breast phantom, we can get, or let's say the machine can transmit and receive scattering signals. In that way, the antenna can be investigated in the time domain for imaging purposes. So we can use time domain algorithm and frequency domain algorithm in order to get better results. So for this part, we are using time domain. The efficiency of the antenna arrays in the imaging and treatment may be improved by increasing the number of the elements. So as we can see here, this is the tumor, and these are the parts that's skin and bone and the others. So we make sure, or we concentrate on the skin, because we have the permittivity of the skin and the radiation that can enter through it. So the arrays should be more than, or could be several arrays in order to get better results, and so on. The antenna arrays in the imaging treatment should be improved in order to get a number of elements. So, as I said, we use the algorithm that we can get better results. I mean, FDTT procedure algorithm is used to obtain data for ultra-wideband microwave imaging techniques from the numerical cylindrical units. This is the tumor. This is the tumor, and this is the breast phantom. And we started using the algorithm in order to get, in order to connect and record the results and the data through the computer and the CPU. So the elements have had their turn to transmit a total m times m backscattered signals. We are getting a dimension of the scattered signals in order to get registered and then injected to the computer, in order to the algorithm that is in the computer, in order to get the image. To improve the identification of the 3D grid, I mean, with 3D grid, we can get delta x, delta y, and delta z dimensions in order to see how much is the dimension in 3D, and how much is the length of the wave. How much is the wavelength that can radiate through the antenna and can touch the breast. Lambda divided by 4. So, as a result, the image resolution is determined by the frequency and bandwidth of the service. Higher operating, as we presented before, higher operating frequency in the bandwidth means we have got more bandwidth in the creation of the high resolution files. So we can create high resolution files, and the simulation frequency range started from the range 1 to 22 gigahertz. From 1 to 22 gigahertz, which is in the sufficient range that we wanted for the application. Here it is starting, and it is in the range of the applications. It's coming to the 22. So the finding of the traditional umbilical ultra-wideband antenna sensor network for the middle of the 11, we have resonations here in 11. This means that is the place that we wanted for our application. Then, as presented in this curve here, the spike in bandwidth as the number of antennas increased. So the bandwidth is low when the antenna only has one part. So we have got less bandwidth when we use less antenna arrays. So in particularly at the lower end of the working bandwidth, we have got lower bandwidth. So overall, the overall results for the antenna has a large bandwidth ranging from 3.65 to 21 gigahertz and from 23.1 to 30 gigahertz, and the smallest band at 22.4 gigahertz, allowing to be operated for the applications for industry and medical, ISM band. So the proposed array antenna also has a nominal gain of 6.77 decibels and a peak beam width of 8.34 dBi and a radiation pattern of more than 55%. At a higher band, the percentage rises to 90%, and the antenna has a high SAR radiation for both standards. It is in the standard, it is always less than 2, which is in the standard as standardized by European standardizations. Finally, I would like to talk about the conclusions. So wireless sensor networks have been seen offering a variety of purposes tested and respective. The use of a network of the antenna sensors for imaging and localizations is an emerging application of wireless sensor networking. The ultra-wideband antenna sensor network was used to locate and photograph the tumor in this article. The overall data were transferred to MATLAB to rebuild or reconstruct the image of the tumor in the skin and to find it in the exact spot, the localization. So here we finished. Thank you very much, and thanks for listening.
Any question, please?
Is there any question, comments, or remark? No question. Thanks again for your presentation. So next speaker is Nada Hassini. The title of the talk is Higher Layer Thickness Influence on Multiple Sizes and the Fact Appelling of TI64I4Y at High Scan Speeds.
Hello, hi everyone. Today I will present our work entitled High Layer Thickness Influence on Multiple Size and Defect Appearance of Titanium Alloy at High Scan Speeds, presented by me and guided by the co-author Mr. Sami Shati and Mrs. Munir bin Sina. We start with the introduction. Subtractive manufacturing starts with a block of material that we subtracted until obtaining the desired part. This type of process leads to a waste of material and limited capability to manufacture complex shapes. In this context appears the process of additive manufacturing. We start with a powder material, then we add material progressively, layer by layer, until obtaining the desired part. AM presents various advantages. It allows us to create complex shapes difficult to build with conventional process. In AM, there is no need to use specific tools such as molding. Also, saving material. At the end of the process, unused material is recycled for further use. And finally, diversity of material that can be used. AM is used in several fields, such as medical sector. We can create personalized prostheses, also in aeronautic, automobile, and molding fields. The basic material of AM can be divided into three groups. It can be in the form of liquid, and here we say the process of stereolithographic in the form of filament, fused deposition modeling, and in the form of the powder bed, and here we state the process of selective laser melting. Our chosen process is the selective laser melting because of the variety of material that can be used, the high precision, the no need for post-treatment, and the possibility to manufacture complex chips. We move now to SLM process and goals. The mechanism of the process is shown through this figure. As you can see, the powder particles spread on the metal base plate will be melted completely and fused together layer by layer under the effect of a laser beam that follows a given scanning path. AM implies various parameters related to the material, such as size of powder particle, thermal and mechanical property, related to the part, related to the heat source, such as laser power and laser beam diameter, and parameter related to the machine, such as scan speed, layer thickness, and touch spacing. SLM is a very complex process. A poor control of this parameter often results in defect porosity, such as lack of fusion, balling, and keyhole. The balling defect consists in the formation of spherical masses on the powder bed surface after laser scanning. Lack of fusion appears as the provided energy is not enough to fuse the layer of powder to a significant depth, leading to a large and a very severe voids in the part as built. Looking at the previous work, it can be seen that there is a lack of simulation on the effect of high layer thickness and scanning speed on melt pool dimension and on final part quality. Therefore, a better understanding of this process by analyzing this effect is needed. So, our goals are to predict the effect of high layer thickness and scan speed on melt pool dimension and therefore on porosity defect, and to validate numerical results by experimental results from literature. We move now to results and discussion. We used the single beat parametric simulation, which is a tool from the software ANSYS additive, used to obtain information about the melt pool dimension of selected material. Our chosen material is the titanium alloy due to its high strength and also its suitable alloy for a wide range of application. The input of our model are the length of bead, the laser power, the layer thickness, and the scan speed. The outputs are the melt pool depth, the melt pool width, and the melt pool length. This figure highlights the effect of layer thickness on melt pool depth. We know that the highest layer thickness and lowest scan speed combination present the highest melt pool depth. The melt pool depth show a relatively lower value at the 14 micrometer layer thickness in comparison with value at the 20 micrometer layer thickness. This trend is present for all levels of the investigated scan speed for thickness between 20 and 14 micrometer. And this is maybe caused by the fact that more laser energy is necessary to melt a thicker layer of powder, leading to a limited energy penetration during the formation of the melt pool. Basically, an upward trend is found in the depth starting from the thickness 14 micrometer. The depth increase as the layer thickness increase. This upward may be attributed to the fact that high absorptivity is required for a thicker layer of powder, therefore larger and deeper melt pool, which may redress the previous effect. Thus, an interaction between these two phenomena resulting with no depth in this discrepancy in melt pool depth from 20 to 14 micrometer. So in that range of thickness, the first effect is dominant. The melting of a thicker layer needs more energy than a thinner one, and therefore we obtain a shallow melt pool depth. Also, we note that when using a relatively high thickness of 100 micrometer, the depth value tends to be closer for all scan speeds level. We conclude that the effect of scan speed on melt pool size is not significant for this limit of layer thickness. For the width of the melt pool, the width presents also an increase as the layer thickness increase for the same reason. The thicker layer could lead to the increase of laser absorptivity, which could make the melt pool width more larger. Our results present the same trend with the experiment shown through this figure. As we see, the melt pool size increase as the layer thickness increase from 16 micrometer to 100 micrometer. Improperly chosen parameter could generate many defect porosity in final part. Therefore, some criteria can be implied on melt-pool geometry to avoid these defects. To avoid appearing the bowling defect, the ratio between the length of the melt-pool and the width should be less than 2.3. To avoid the lack of fusion defect, the ratio between the depth of the melt-pool and the layer thickness should exceed 1.5. These criteria are derived from empirical observation, physical principle, and pure geometric consideration. The layer thickness effect on porosity appearing is demonstrated in this figure. The green data points indicate that the presence of the bowling defect. The data points in orange are the layer thickness and scan speed combination, indicating the presence of the lack of fusion and bowling defect. As we can see, only bowling defect is present until reaching the layer thickness value of 16 micrometer. From this value, both bowling and width are present. For the same scan speed, 2,400 micrometer per second, increases thickness from 20 to 100 micrometer leads to more porosity. Our results are validated experimentally from the literature at the same condition. And here we morphology observed confirms that there is a strong correlation among the predicted and experimental results. It is essential to note that increasing the layer thickness combined with high scan speeds was more prone to produce large open voids and irregular shapes, which are more pronounced, especially with high layer thickness 100 micrometers. By comparing these two morphology A and D, we note that for a constant layer thickness 20 micrometer, when the speed increased from 2,300 micrometer per second to 2,400 micrometer per second, the bowling particles are more serious and numerous with larger sizes. In fact, a larger layer thickness could enable a big melt pool. The melt pool is far away from the substrate, leading to a relatively small contact zone between the melt pool and the substrate. In this condition, the small wetting area could not support the big melt pool. Thus, the melt pool tends to break up into balls. We move now to conclusion. Our results have shown that using a thicker layer thickness at high scan speed enhances the generation of porosity defect. So, more research investigation are required for a deep understanding of each parameter's effect on defect appearing using a thick layer. First, reference used, and thank you for your attention.
Thank you very much for your talk. Is there any question, comments, or remark? Thanks again for your presentation. Title of the next talk is Development of the Single-Axis Well Speed Sensor Hill Test Bench of Vehicle Velocity Control. Name of the speaker is Yanis Kreb. You can start.
Okay, so can you see my screen?
Right.
Thank you very much. So I'm going to talk about the development of a single-axis wheel speed sensor, hill test bench for vehicle velocity control. My name is Yanis Kreb, and I'm doing a cooperative PhD between the Universidad de Cádiz in Spain and the Frankfurt University of Applied Sciences. And I'm doing some research on velocity controlled scooters to get a more ecological effect and to give a smart alternative to conventional restrictions like they are used in 50cc scooters. So at first, I'll give you a brief introduction, then my hardware-in-the-loop design, some simulation and control, and at the end, of course, the results and a small conclusion. So wheel speed sensors are small sensors that are placed very close to the wheel nut. Here you can see it behind the brake disc to sense the dynamic of a wheel. And wheel speed sensors are used since decades. At first, they were passive sensor elements, so they just delivered an induced voltage. And today we are talking about active sensors. So they are providing a digital signal that is modulated onto the current of the sensor on the signal line. Then let me give you a brief introduction to hardware in the loop. So hardware in the loop is a technique or a test approach that is very popular today. So every car manufacturer or car supplier is using it already. And you can whether test standalone, which means you can test one hardware component by itself or in context of a bigger system. And here in the lower right side, you can see an illustration that shows you there's one component, in this case, it's the hardware under test, that is tested in the real world, and the input and the output is simulated. So the plant model, in this case, it's the dynamic of the vehicle, of the scooter, is simulated through MATLAB Simulink, and the input is synthetic as well. So you have a test suite and an evaluation, and you can test. And the best disadvantage, the advantage is that you can improve the reproducibility enormously, because you can test 1,000 times under the same test conditions. So this enables you to parameterize or to do some better failure detection. And you can lower your costs extremely because you can test earlier. So normally you're testing after your development is done, and here you can test this at the same time. So in every development step you can test and can save a lot of money. So the intended hardware in the loop test bench, I tried to implement 2 active wheel speed sensor elements using real world hardware. So in this case, the wheel speed sensor is the real world hardware, and a synthetic environment, which means that the plant model is simulated through MATLAB Simulink. And I wanted to get a very precise and stable velocity measurement on only one single axis. So imagine normally on motorbikes, or when it comes to the automobile, we have 4 axes or 2 axes, and we can just get the speed out of this 4 measurements. And in this case, I just wanted to get that precise and stable measurement from only one single axis on a motorbike, or in this case, more precisely, the scooter. So the hill design divides into 2 parts. On the one hand, the computer, on the second, the hill test bench. So we have a simulation, MATLAB Simulink, including the scooter model, so the longitudinal dynamics of the scooter and the control. Then an interface for sharing information with the hardware in the loop test bench, and the test bench itself consisting of an ECU, UART USB converter for interfering with the computer. Then we have some HMI components like switches in the display. We have a power supply, 12 volt and 5 volt for all the components. And here in green, you can see the encoder disk powertrain. So we have a stepper motor control, a stepper motor, and the encoder disk that is normally placed behind the wheel hub, like from a motorbike or a car. In this case, we have not only one sensor, it's a redundant system with 2 sensor elements placed behind this encoder disk, and then a comparator for the pre-processing of the signals before the transmission to the ECU. So let's talk about the development of the encoder disk powertrain. So at first I tried to set up a system with a DC motor, afterwards with a brushless engine, and at the end I'm happy with the bipolar stepper motor, because I do not need any gearbox, but of course I have to provide some pulses or a frequency that triggers the stepper motor controller to reach a certain speed. And the advantage is that we can reach speeds near to 0 revolutions per second. So when talking about DC motors or brushless motors, then this is not the opportunity, because we have a threshold of a minimum revolution per second. And we have a linear behavior when it comes to control, because we have the requirement of the precise encoded disk speed and a quick and accurate control, which is not given with a DC motor or a brushless engine. 2 things we have to talk about is the speed range and the error proneness. So when it comes to the speed range, and we say that a scooter has typically a wheel diameter between 16 and 20 inches, then at a 55 kilometers per hour, it's resulting in a 10.5 revolutions per second. And this small stepper engine, which is a NEMA 11, gets a maximum speed of 12 revolutions per second. So this is the tested value, and this is within the range, and it's totally working. Why is it that way? Because with increasing speeds, the inductive resistance inside the engine is also increasing, and at one point, the magnetic field is faster than the rotor, and then it comes to a total still stand. And this issue leads to the error proneness. So if we have any fast load changes or rough changes, then we can provoke a still stand. But it's not a big deal because the acceleration of a scooter with less power, so we're talking here about 3, 4, maximum 5 braking horsepowers, so the acceleration is much slower than the acceleration the stepper motor can supply. So this is not a big deal and no problem. Let's talk about the wheel speed sensor measurement itself. The sensors used are wheel speed sensors from the very popular motorcycle company KTM, more precisely the Duke 790, the front wheel, and the type, it's an active magnetoresistive sensor, and the encoder disc has 48 steps per revolution. And here in this image, this is the setup of the normal front wheel of the motorcycle. Here you can see the encoder disc, and this cable is belonging to the single sensor here placed in the center of the wheel. And there are two possibilities of measuring the speed. One is counting the edges in a predefined time period, which means that the resolution of the measurement depends on the time period that I define, or the amount of edges that are, of course, depending on the resolution or the encoder steps. The second possibility is measuring the time period between two edges. It doesn't matter if you count the positive or the negative ones. And in this case, the resolution of your measurement only depends on the timer resolution. And of course, nowadays where we have very fast ECUs, this is not the problem, and we can provide very high clock frequencies. And that way we get a very precise measurement on the time and later the velocity. So here you can see part of the test bench. This is the encoder disc that is just rotating above these two redundant wheel speed sensors, which are totally adjustable in the distance to the motor as in the height by this carrier to control the air gap between both sensor elements and the encoder disc. The HMI is quite simple. There are some push button switch, toggle switch for operating, and as output we have an LED giving some system state and an LCD for operating through the menu, for example. I have implemented 4 different operating modes. At first, the closed loop, where the velocity command comes from the simulation and the feedback the test bench follows this velocity and feedbacks the measured velocity. Then we have the open loop, where the velocity command comes from the simulation and is followed, but there's no feedback. Then we have the automatic test mode, where the test bench is just accelerating from 0 to the maximum speed and back, and the manual test, where the operator can directly define the speed to test the powertrain, to test the measurement in the whole setup. The interface is quite simple because the ECU is providing a UART and the computer serial interface through the USB connection. So there is USB to UART device or converter. And of course, we have to implement this communication in MATLAB Simulink as well. So here you can see that I have used these stream in and output blocks that enable a serial communication for reading and writing the velocity values. Let's talk about the simulation and the control. So the simulation is based on this equation. The force that is needed for the propulsion of the system equals the sum of the mass inertia, the air resistance, and the rolling resistance, which is given in a nonlinear second order differential equation that then needs to be transferred to a flowchart like typically done in MATLAB Simulink. So here you can see the same components. At first the mass inertia, then the air resistance and the rolling resistance. And on the left side, you can see a very brief simulation of the motor characteristics, including the combustion powered engine, the clutch behavior, and the barometric driven gearbox of the scooter. The controlment is done with a velocity control. So we have 2 inputs. At first, the velocity given by the 2 wheel speed sensors. So this is the measured velocity. And second, the input, which is the throttle demand of the driver. As output, we have a motor power regress, which means if we have a 0%, then we have 0 watts of power. And if we have a 100%, then we're talking about 2,300 watts. So this is an example of a Vespa 50. Now talk about the results. Here you can see the closed test bench from the front. So at top, the encoder disk, the two wheel speed sensors mounted below, the sensor carrier that is, like already mentioned, adjustable, in the stepper motor right here. And as the human machine interface, we have the mentioned buttons, a liquid crystal display, and here from the hill emblem, the Y dot is the system state LED. When you open up the test bench, you can find the stepper motor controller on the upper right side. So this red block is the stepper motor controller. Below, it's not visible here, is the 5 volts power supply. On the left side here, the comparator for pre-processing the two sensor signals. We have a 12-volt power supply. This small device on the right is the UART to USB converter. And here, the very well-known ECU Nucleo 64 board. So now I have prepared a little video clip for you. So on the left side, you can see in real time the test bench running, and on the right side, the belonging signals. So in yellow, you'll see the throttle demand, which is a randomly given throttle demand of the rider. And in orange, you can see the simulated velocity, and in blue, the measured one. The parameters like the wheel size, the filter size, and the encoder resolution, and the minimum and maximum velocity has, of course, a big impact on the characteristics that you can see here. The wheel size, because the blue, the measured velocity here is filtered with a moving average filter that adapts its window size to the velocity. And you can see in this illustration that for positive accelerations, the measured or simulated velocity equals the throttle demand, but we have no braking access on this test bench. So it's only simulating the positive, the motor request. So when it comes to negative accelerations, the mass inertia of the scooter is just leading to, let's say, a rolling out of the scooter element. So these parameters can be adjusted very easily through the menu of the test bench. And so there's not a big software effort on coding when it comes to any changes or if you have to adjust your test bench. So let's come to the conclusion. It's a low-cost hardware-in-the-loop test bench that costs less than 300 euros, so it's something like $320 at the moment. And I have implemented the redundant active wheel speed sensors to get a very precise and stable velocity measurement on just one single axis, on the rear axis. And I'm able to test different scenarios through the implementation of different operating modes. And the adjustment of parameters is quite easy. So I'll use the test bench for further research on velocity controlled scooters, because this was just the first step of my PhD. Thank you very much for your attention. And if you have any questions or any feedback, I'm very open for it. Thank you very much.
Thank you very much for your talk. Is there any question, comments, or remark? No question. Thanks again for your presentation.
You're welcome.
The title of the next talk is Focused Crawling Application for Building Corporate Knowledge Base. Name of the speaker is Neko.
Hello.
Hello.
My name is Neko. I'm a PhD student from Rusi University in Bulgaria. And here with my mentor, Svetlana Stefanova, which is associate professor from the same university, we present a study of possibilities to use focused crawling for needs for building the corporate knowledge base. Actually, the target is not just corporate, not just companies, but also any organization. What does crawling means? Probably you know. Crawling is a process of collecting information from the World Wide Web and indexing this information or storing just part of this information for some needs. Focused crawling, as opposite of the general crawling, is collecting information which is related just to some particular domain or just for some particular user needs. What is the difference between focus? The focused crawling, the difference between needs of the company and using the okay. There is a difference between companies collect information and, for instance, big index engines collect information. The difference is that the companies have a text body. Companies can generate also information with their own tools within, and this information is could be hidden behind virtual private network. That's why this information could not be possible to be indexed by global processors like Google. So in this case, we need a different way of processing not only internal information but also information on the internet, which is related to domain in which a company operates. How is this focused crawling performed? There are 3 strategies available so far. First, you need to prioritize the content that you are going to collect. Prioritization is made on the crawling frontier. This is the part of the content which is still to be collected, which is not yet downloaded, but is going to be collected. Training is also needed because focused crawlings need to know what exact information to be downloaded. So not every information be downloaded, but only part and related to the domain. And because we need to separate domain content from the other content in the global net, we need also a classification of this information. So the third strategy used is a classification of the information to be visited. What are the main approaches available so far in the focused crawling? The best first crawlers actually use technique to visit a page, to select page to visit on each subsequent step. So they select which page need to be downloaded on each following step. And different here they use different algorithms like term frequencies, inversed document frequency algorithm, which measure the frequency of terms that are met in the documents, and also they could use another, sorry. Actually, best first crawlers use mainly techniques that are related to linguistic match, and as opposite semantic crawlers use some semantic techniques to find content, not just by linguistic, but using actually using a semantic search. In this case, global sources like WordNet or Wikidata are used. And here we have 3 kinds available of semantic crawlers. Crawlers that are based on ontologies, where predefined ontologies and comparison of content to this predefined ontologies is used. Another type of semantic crawling is using a metadata of documents, again compared to predefined ontologies. And other semantic crawlers use combined techniques. Learning crawlers mainly use algorithms from machine learning, and they need a predefined set of training data. Here, a very influential algorithm is possible to use.
Nico, server briefing, you can shift your slide. You only see the first slide, okay?
Just a moment. Is it better now?
No, we only see the first slide right now. Now, okay, now.
Okay. So in the learning crawlers, very popular is context-focused crawler, which has 3 phases of crawling. Here, information is actually we have a target page, and we have a collection of several layers, and every layer is a collection of pages that have links to this target page, and these layers ordered so the nearest layer has only one link in the path to the target page, and the last layer has n path length to the target page. So the training data is collected in this several layers. And the next step, we have a classification page where we define for each layer, we define a class which could be later used for classifying the page that are going to be downloaded or visited. And the last step in this algorithm is to visit pages and to predict what exactly content is to what exactly layer content is close. So they could be visited or rejected. Also, in the process of crawling, there could be another collections of or initialize phases be made. So the training process could last through all the process of the crawling. So as a conclusion, we found that companies could use, actually the companies and organizations have quite a lot information within their intranets comparing to the World Wide Web. And actually indexing and crawling internal intranet information is quite easy to do. But when it comes to collect information, domain-related information from the World Wide Web, we will need one or a combination of one of this a combination of these methods of focus scrolling. So that's all for me. Thank you. If you have questions or comments.
Thank you very much for your talk. Is there any question, comments, or remark? No question. Thanks again for your presentation. Now, the title of the next talk is Efficiency and Acceptance of Virtual Classroom During COVID-19 Bangladesh Perspective. Name of the speaker is Nabarun Haldar.
Yes, I'm present. I'm presenting my presentation. So please see my slide. Can you see?
At now, just a second. Yes.
My screen is blinking. Okay. Hello, everyone. I am Nabarun Haldar. Today, I will present our work titled Efficacy and Acceptance of Virtual Classroom During COVID-19, Bangladesh Perspective. This is a group work, human-computer interaction researchers from Daffodil International University, Bangladesh, and Pabna University of Science and Technology, Bangladesh. And my co-authors are S.M. Rakibul Islam, M.D. Sarwar Hussain, Ishtiaq Ahmed, Ashraful Islam, Sheikh Rashid Haidar Nouri. As we all know, COVID-19 is around here for over a year, and the tragedy of COVID-19 is horrible. When the coronavirus spread worldwide, communications were cut off, people were trapped at home. According to UNESCO, before mid-April 2020, over 1.5 billion children and youth had been affected by COVID-19. To stop spreading the virus, any gathering is prohibited. Educational institutions were forced to close. After the emergence of COVID-19, online education system had been introduced worldwide. Bangladesh was no exception. The government of Bangladesh introduces some policies to continue educational activities online. Online classes have been conducted using tools like Google Meet, Zoom, Microsoft Teams, etc. Online classes have been running for more than a year in Bangladesh. People are wondering, will it continue after COVID-19? And question arises about the efficacy and acceptance of online classes. It is only possible to determine the effectiveness and acceptability of the online classes only by knowing the opinions and views of students. This paper presents a study on the efficacy and acceptance of virtual classroom among students from Bangladesh during COVID-19. Now, in terms of methodology, to know the views and opinions, we did a survey. Our survey was web-based. The survey conducted in spring 2021. A questionnaire was developed using Google Forms and circulated to those who attended online classes during COVID-19. Our questionnaire was a set of qualitative and quantitative questions. Before final question set, a standardized and unstructured preliminary questionnaire was developed with the help of literature review and informal conversation with students who participated in online classes. Our survey was attended by 210 students ranging from high school to postgraduate across Bangladesh. We performed both qualitative and quantitative analysis to analyze our survey data. We used Google Forms built-in features and Microsoft Excel. Now let's see participants' demographic information. We can see that most of the participants in our survey are undergraduate students, and the number is 186. Among 210 participants, 142 participants were male and 68 were female. And the age range of participants, majority from 18 to 25, and the number is 195. And our participants' residence area, urban was for 133, rural was 43, and suburban was for 34. Now, what are the findings from our survey? Among 210 respondents, in terms of access to virtual class, they mentioned they have never done any online class before COVID-19. We asked for drawbacks of online class. Very few participants said online classes does not have any drawbacks, but 143 respondents found it is difficult to understand lectures in online class. About concentration, 151 respondents stated it is tough for them to concentrate in the online class. 128 participants found that online classes are damaging their eyes because of long time staring at the screen. Internet connection is necessary for online class, but 45.2% of participants reported that they do not have a seamless internet connection. Now, if we look at how participant access to virtual class, table data shows that most of the participants used Android computer and laptop computer, but the number of Android smartphone users is 161 and laptop computer is 108. In terms of internet accessibility, 121 used mobile data, 103 used broadband connection, and public Wi-Fi accessible to 36. And the platform participant used, Google Meet used by majority participants, and the number is 163. In terms of communication with new classmates, 150 participants said they used Messenger and social media groups. Participants used personal messages, but a significant number of participants, like 60, never communicated with new classmates. And the peer communication, 79.5% respondents said online classes creates distance between classmates. They stated their opinion about group study. Participants found that group study is hard to attend because everyone is at home. We asked the participants how interactions with the instructor have changed. They said it is hard for the instructors to keep track of every student online. And they also said online communication with the instructor is ineffective. Nearly half of the respondents felt less motivated to get in touch with teachers if they had issues after class. Now, what about tests in virtual class? Alongside online classes, online tests are also a major part. And in the matter of giving online tests, participants gave a divided opinion. Some said they liked it and others said they do not like it. They also said there are lots of network problems throughout the online test, which affects their results in often and too late to acquire questions. In terms of difficulty, participants said because of open book exams, teachers tend to create more analytical questions that are difficult than normal tests. And this said assessment differs from instructor to instructor. In terms of study habit, most of the respondents observed that the stress of online classes all day has limited their own study time. Now, what are the distractions in online class? In terms of distractions in online class, respondents found themselves distracted if the class time is longer, and they mentioned home environment is not suitable for class. Noisy environment and network issues create distractions in online classes too. In addition, fewer interactions with teachers and classmates make them lose concentration in online class. Now, if we look at this chart, the number of votes from participants about how they prefer to have their evaluation on the class lectures and materials. And the chart data shows that participants like the evaluation end of every class is 52, and 49 participants said they liked evaluation if the evaluation is every class but on the previous class topic, and 65 participants said the evaluation they preferred end of every week, and 44 said they like the evaluation end of the course. If we look at the Likert scale chart, that the number of votes from participants about how lecture materials are changed. Likert scale valued from 1 to 5, where 1 was for changes, no changes, 2 was for support changes, 3 was for neutral, and 4 was for very changes, and 5 was for extreme changes. And the number shows the 22 find no changes in lecture materials, 24 said somewhat changes, and 87 are neutral, 4 saying 56 said very changes, and 21 said extreme changes. Now, in terms of change in instructions, participants said teachers spend less time teaching a topic. Instructors use less imagery to demonstrate a topic because they teach using digital media, which is tough to draw images. And they say teachers take less feedback, and most of the teachers do not use online writing tools. It is a hardware limitation. Instructors do not have writing tools or a writing pad. Respondents said online classes are not often efficient for them. Now, if we look at this chart, which is learning through virtual class, about confidence. The number of votes from participants about how confident they are in terms of learning through online classes or a Likert scale, we can see it was also valued from 1 to 5, where 1 was for unconfident, 2 was for slightly confident, 3 was for neutral, and 4 was for very confident, 5 was for highly confident. And the number shows 36 find they are very much unconfident, and 2 was for slightly confident, and 3 was for neutral. 70 participants are neutral, and 38 participants said they are very confident, and 25 said they are highly confident learning through virtual classes. Now, in terms of student-teacher interaction, how it's changed, it was also a Likert scale question, and the data was valued from 1 to 5. 1 was for extremely unsatisfied, 2 was for slightly unsatisfied, 3 was for neutral, and 4 was for very satisfied, and 5 was for extremely satisfied. 39 participants said student-teacher interactions, they are unsatisfied. 2 was for 44 participants said they were slightly unsatisfied, and 58 participants said they are neutral. And 41 participants, they are very satisfied about student-teacher interactions, and 28 found them extremely satisfied about student-teacher interactions. In terms of asking questions in online class, most of the students ask questions to understand a topic, but nearly half of the respondents do not feel motivated enough to ask questions in the online class. In addition, there is a tendency among students to learn from recorded lecture videos rather than in live class. If we look at this virtual class benefits, students voted. It was also a Lycard question, and 1 was very determinal, 2 was for somewhat determinal, 3 was for neutral, and 4 was for very beneficial, and 5 was for extremely beneficial. And the benefits, in terms of benefit, 36 participants found very determinal, and 38 participants said somewhat determinal, but 66 participants were neutral, and 41 participants find them online class very beneficial, and 29 participants find online class very extremely beneficial. Now, from these findings, if we summarize it, we found some key points which makes us to take any kind of comment or decision. And the summary of findings are: most of the participants did not attend any online class before COVID-19. Sometimes it was difficult to understand lectures in online class. Being focused for a long time was hard for them. It was harmful to their eyes looking at the screen for a long time. Home environment is not suitable suitable for classes. Online classes creates distance with classmates. Everyone did not have seamless internet connection. Students don't feel motivated enough to ask questions in online class. Majority participants said they did not like to attend tests in online format. Most of the teachers do not using writing or drawing tools because hardware is limited. Participants want equal focus on every student. Now, if we come to a conclusion, to analyze this data, we can say according to the student responses, advantage and disadvantage have been highlighted in the context of our study. If the current flows in online class are addressed and teachers can be focused for every students in online, then online class can be a viable option for students in general. And that's all for our work. Thank you.
Thank you very much for your talk. Do you have any question, comments, or remark? No question. Thanks again for your presentation.
You are welcome.
So the title of the last talk of this session is Machine Learning Approach for Item-Based Move Recommendation Using Most Relevant Similarity Techniques. Name of the speaker is Mianur Rahman.
Actually, I'm presenting our paper from our team. Do you see my screen? Hello.
Yes, we can see you.
Yes, you can start.
Okay, thank you. Assalamu alaikum. I would like to express my heartfelt gratitude to all of you, dear all participants and panelists. My warm welcome. Hora is going well successfully in its third international e-conference. I'm happy and lucky being a part of this amazing platform for the researchers. Today, I'm presenting machine learning approach for item-based movie recommendation using the most relevant similarity techniques. Before presenting my paper, I would like to introduce myself. I'm Sumaya Khanpriti. undergraduate student from Southeast University. And my co-authors are MD Mizanur Rahman, Assistant Professor, Department of Computer Science and Engineering, Southeast University. And Jiyad Abdul Bari, he is also undergraduate student from Southeast University. So this is the overview part of this presentation, and I'm going to explain all this topic. Well, we know in our daily life, we are very dependent on the internet for entertainment, shopping, business, and so on. So the number of items and users are increasing extremely. Basically, it is difficult for a user to find out his desired item. So to solve this problem, recommendation system works. So the recommendation system is a revolutionary technique which has transformed the applications from content-based to customer-centric. Well, there are different approaches of a recommendation system. So in our work, we have used collaborative filtering approach. Actually, a recommendation system based on correlations of user interest, mostly generated by the collaborative filtering approach, and it is capable of providing better prediction. And there are also another important part of collaborative filtering, which is find out user similarity and item similarity using ratings. So one of the reasons why we have picked up this topic in our research work. So far, there are several research work done into this topic, and they introduced different similarity techniques for item-based and user-based recommendations. And those are Pearson correlation, cosine vector, constraint Pearson correlation, sigmoid function-based, and so many. As there are different similarity used, so it is difficult to choose which one is suitable for the desired recommendation and which one is better. So in our research work, we have presented item-based filtering for movie recommendation and applied similarity techniques, so which are Pearson correlation, cosine vector, and Spearman rank correlation. We implement them on the same dataset for choosing a techniques which provide better accuracy. So this figure represents methodology of our research work. Here we used item-based collaborative filtering, and we used a dataset from Kaggle, which is 20 million movie lens dataset. Then we applied similarity techniques. After that, we predict unrated item using a similarity value, and then we checked accuracy by using RMAC and MAE. So we used a 20 million movie lens data set, which is organized by group lens, and it contains several files, but we have used only rating CSV and movie.csv files. Rating.csv file contains rating, user ID, movie ID, and timestamp. On the other hand, movie.csv file contains movie ID, movie title, and genres of movie. This figure represents the implementation procedure of item-based filtering. So firstly, we loaded two datasets that contains user rating and movie data from movie lens. Then we merged after that, we merged two dataset and remove unnecessary column. And for similarity measure, we made a pivot table in order to make rows for user and columns for movies. Then we measured similarity below using similarity algorithm. Then we predict rating for unrated items. So here we present similarity measure algorithm that we have used. Well, this is Pearson correlation coefficient. And the Pearson correlation coefficient is a measure of the strength of the association between two continuous variables. And so this is the formula of Pearson correlation coefficient. In this formula, U and P are two users. IUB is the list of the rated item, and RUI and RPI is the rating of item I, which is rated by user U and P. And R-U and R bar P is the average rating of rating, which was provided by user U and V. So cosine method is another algorithm. Here, so mathematically, it is measures the cosine of the angle between two vectors projected in a multidimensional space. This is the formula of cosine method. Here, U and V are two users. IUV is the list of an item which is rated by user U and V. RUI and RPI is the rating of item, which item I, which is rated by user U and P. So lastly, the Spearman rank. The Spearman rank correlation coefficient is a measure of relationship between two variables when data in the form of rank orders are available. This formula represents Spearman rank correlation. Here KUI is the rating rank of item I for user U, and K bar U is the average rating rank of user U. So basically, by using similarity measure value, we predict rating of unrated item. This is the formula that we have used for rating prediction. In this formula, Sij is the similarity between movie I and movie J. Xj is the rating of a particular item, J given by user. So after rating prediction, we need to check the accuracy level. That's why we choose MAE and root mean square error as a prediction error evaluation matrix. Actually, RMSE has been used for the fact that it penalizes less accurate predictions more heavily compared to MAE. This is our experimental result. In figure 3, we can see that MAE value of Spearman rank is 0.03, and on the other hand, Pearson correlation and cosine vector is 0. So we can see same as the figure 4, the RMSE value of a Spearman rank is 0.05. And on the other hand, Pearson correlation and cosine vector has 0. So we can say then the Pearson and cosine vector provides better accuracy than Spearman rank. Further, we will work work with more similarity algorithms like constraint Pearson correlation, sigmoid function-based PCC, mean square difference, checkered similarity, frequency weighted Pearson correlation, discounted similarity. So we work with them for choosing a similarity which might provide better accuracy. This is our important references that we have used for our research purpose. So do you have any questions? I will try to answer. Thank you so much.
Thank you very much for your talk.
Welcome.
Any question you have? Comments, remark? No question. Thanks again for your presentation.
You are most welcome.
Dear participants, thank you very much for your participation to this session and the this international conference. So we have completed decision and amending decision now. Do you have any questions related with the conference or anything else? Thanks again for your participation.